Hello everyone, this is Pre-Calc Lesson 39, the radian measure of angles and the forms of linear equations. We're finally getting into radians. I don't know if you're excited about that or not, but I'm excited. So radians, the actual definition of a radian, is the measure of a central angle and arc formed if a length of one radius of a circle is measured on the circle itself. You don't need to know that, it's just kind of a fun fact. But what does it mean? The exact measure of a full circle is 2 pi radians. The exact measure of a semicircle is pi radians. And if we were to convert from degrees to radians, you multiply by pi over 180. And if you're to convert from radians to degrees, you multiply by 180 over pi. Okay? So, we're going to revisit the unit circle. I'm now going to show you how to fill in everything else. So this is still 0, and now all the way around is 2 pi. Now this measure here is 30 degrees, but 30 degrees is pi over 6 radians. Now I'm going to ignore this middle line for a second. Okay, let's go to this next line. We know that this next line here is 60 degrees, right? So to go from 30 degrees to 60 degrees, we add 30. So I'm going to do pi over 6 plus pi over 6. Now, pi over 6 plus pi over 6, here's my scrap paper, gives me 2 pi over 6, which simplifies to pi over 3. So this is pi over 3. Let's add another 30 degrees. So 2 pi over 6 plus pi over 6 gives me 3 pi over 6, which is pi over 2, which is right here. Is this what we know is 90 degrees? Let's add another pi over 6. So 3 pi over 6 plus pi over 6 gives me 4 pi over 6, which is 2 pi over 3. So this value here is 2 pi over 3. Add pi over 6 again. 4 pi over 6 plus pi over 6 gives me 5 pi over 6. So this is 5 pi over 6. If you add pi over 6 again, you get 6 pi over 6, which gives you pi. Add pi over 6 again, gives you 7 pi over 6. Add it again, gives you 8 pi over 6, which is 4 pi over 3. We add it again and we get 3 pi over 2. So 3 pi over 2, we had 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6 is 5 pi over 3. And 11 pi over 6 is 11 pi over 6. If we add one more, 12 pi over 6 equals 2 pi. We've gone all the way around. What? So almost all of the angles you can get by just adding pi over 6. Now let's look at this middle angle. This middle angle is 45 degrees. Now 45 degrees is pi over 4. You can do the same thing with pi over 4. So this is pi over 4. If you add pi over 4 again, 2 pi over 4 gives you pi over 2. Add pi over 4 again, we get 3 pi over 4. Add it again, 4 pi over 4 is pi. Add it again, you get 5 pi over 4. Add it again, you get 6 pi over 4. Add it again, you get 7 pi over 4, and 8 pi over 4 is 2 pi. So these are all your radians. Now, I'm not going to write in all the points. You should have them already memorized. But this is what you would do for the unit circle. Now you can do the full, complete unit circle. Hooray! And what we can also do is problems like this. Evaluate 4 sine pi over 4 plus sine of negative pi over 3. So we draw our triangle still. Pi over 4 we know is here. And we know it's our 45, 45, 90 triangle, so we have 1, 1, root 2. So the sine of pi over 4 is the sine of 45 degrees, which we know is root 2 over 2. So this is 4 times root 2 over 2, plus, now negative pi over 3 puts us down here. Well, let me draw a new graph, that's confusing. Puts me down here. This is pi over 3. And we know that pi over 3 is 60 degrees. So it's our 30, 60, 90 triangle. So the sine of 60 degrees is root 3 over 2. And we know that in the fourth quadrant, this is negative. So I will have 2 root 2 minus root 3 over 2, which gives me 4 root 2 minus root 3 over 2. Let's do a little bit of a harder one. Sine of 13 pi over 3. All right, let's look at 13 pi over 4. I'm going to rewrite this as 12 pi over 4 plus pi over 4. 12 pi over 4 is 3 pi plus pi over 4. 3 pi is really 2 pi plus 1 pi plus pi over 4. So 2 pi, I've gone all the way around 2 pi. I've gone another pi, this is pi over here, and then I've got another pi over 4, which puts me in the third quadrant. Pi over 4 is 45 degrees. So again, I have 1 root 2. So the sine of 13 pi over 4 is the same as the negative sine of pi over 4, which is negative root 2 over 2. Okay, let's look at now negative 5 pi over 3. So we know this is negative pi, negative 2 pi. I haven't gone a full negative 2 pi, right? That is the same thing as negative 6 pi over 3. I've gone pi over 3 short, which means I'm right here. And pi over 3 is 60 degrees. Gone all the way around like this. So I have my 30, 60, 90 triangle. So the cosine of negative 5 pi over 3 is the same as the cosine of pi over 3, which is 1/2. So now I have negative root 2 over 2 plus 3 times 1/2, or 3/2, which gives me 3 minus root 2 all over 2. Yay! Okay, let's do another example. Cosine of negative 25 pi over 6. So let's look at 25 pi over 6. I'm going to rewrite it as 24 pi over 6 plus pi over 6. Okay, 24 pi over 6 is the same thing as 4 pi plus pi over 6. And 4 pi is just going around the full circle twice. So if I go in the negative direction, I've gone negative 2 pi, negative 4 pi, and then negative pi over 6. Now I always remember that pi over 6 is 30 degrees. So this is 30 degrees here. So the cosine of negative 25 pi over 6 is the same thing as the cosine of pi over 6. And the cosine of pi over 6 is root 3 over 2, adjacent over hypotenuse. And 4 pi over 3, we know that this is 3 pi over 3, or pi. So I've gone pi over 3 past right here. And I always remember pi over 3 is 60 degrees. So that means this is 30. So I have root 3, 1, and 2. So the tangent of 4 pi over 3 is the same as the tangent of pi over 3, except all students take calculus. Tangent is positive in that quadrant. And the tangent of pi over 3 is root 3. So now I have root 3 over 2 minus 2 root 3, which gives me root 3 minus 4 root 3 over 2, which is negative 3 root 3 over 2, if I did that math right. Let me check that.
Julia Guevara to the front office, please. Julia Guevara, please come to the front office.
Right on. Okay, so you should be really comfortable with trig functions by now, because now we're making it harder with radians. All right, now let's real quick talk about the length of the arc of a sector. The length of the arc of a sector, the formula is the measure of the central angle in radians times the length of the radius. Okay, so we have this long-winded example. The latitude of a point on Earth is the degree measure of the shortest arc from the point on the equator. So if this was Earth, it's my sphere. Okay, this is my equator, right? And it tells me that the latitude of LA is 34.05 degrees, which I need to convert to radians. So 34.05 times pi over 180 gives me about 0.594 radians. This is in degrees radians, right? The degrees cancel. And it tells me that my diameter of Earth, of the equator, is 7920. So I need to find my radius by dividing that by 2. And it gives me 3960 is my radius. And using our formula, the arc, how far is LA from the equator? So we're looking for this distance, right? So the distance of the arc is my radians times my radius, which gives me about 2352.24 miles. Seems a little more complicated than it is, but all you're doing is plugging it into a formula. All right, we continue. It's kind of a lengthy lesson. Next example. Theo measured the angle between the base of a building and the top of the building. So this is my building. Okay, this is the angle from the base to the top is 0.6 degrees. And Theo was 4,000 feet from the base of the building. Now we're going to draw a really tiny little arc here, okay, which is going to measure the height of the building. Now again, I need to convert 0.6 degrees into radians, which gives me a 0.0105 radians, very small radians. I have my radius, which is 4,000 feet, so the height of my building is 0.0105 radians times 4,000 feet, and it gives me approximately 41.89 feet. Not a super tall building. Okay? All right, almost done. Let's now get into family of lines. These are 4, I'll talk about 2-point form in a minute. These 4 forms of a line, you have to memorize what they are. So general form, we have ax plus by plus c is 0. Slope-intercept, you should be very familiar with. Y equals mx plus b. Double intercept form, x over a plus y over b is 1. We'll use this one a lot. Point slope is y minus y1 equals m times x minus x1. You need to memorize all of these because we're going to be going back and forth between different forms now. Okay? And 2-point form is just writing the slope as y2 minus y1 over x2 minus x1. You really won't need to know that. Okay? Now what we're going to do is something like this. Write y equals negative 7 over 3x plus 1 over 5 in general form with integers as constants. This is in slope-intercept form. So to go to general form, I need to get everything on one side. So I will have y plus 7 over 3x plus 1 over 5 equals 0. Now it wants me to have integers as constants, which means I need to multiply everything by my common denominator, 15, to be able to get rid of these fractions. Giving me 15y plus, now the 3 and the 15 cancel, so I have 7 times 5, 35x, plus 3 equals 0. And there you go. There's my general form. Okay, one more example. Write 2x minus 3y plus 4 equals 0 in double intercept form. So for double intercept, I first need to bring my 4 over. So I have 2x minus 3y is negative 4. Now, double intercept, I need 1 over here. So that means I divide everything by negative 4. So I will have 2 over negative 4x, and then I'll have minus 3 over negative 4y equals 1. I'm going to simplify these fractions. Okay, so this gives me 2 over 4 is negative 1/2 x plus 3 over 4y equals 1. Now, I need to rewrite this so that I have x over a plus y over b. So I'm going to write this as x over negative 2 plus y over, here's the tricky part, I'm going to rewrite this as y over 4 over 3 equals 1. Now look at this, if I have y over 4 over 3, if I have a fraction in the denominator, I multiply by the reciprocal, which gives me 3y over 4, which is what I have over here. I have to write it in a fraction, though, to be in double intercept form. And you have to also put the negative in the denominator to be in double intercept form. Alright, so this was a very long-winded lesson. We'll have lots of practice on all of these. Make sure you know your unit circle because I can spring it on you at any time, even tomorrow. Alright, that's all for today. We'll see you.